So happy to be here. A lot of people. I'm gonna present you a very, I hope, simple way to package data with DuckDB and S3. So I'm Olivier Leroy. That's fine if you call me Olivers. And I write that with John, which is not here. Uh, yeah, I have like some black to wake up, some like dark side to wake you up. So this is me. This is John. We are at the Posit Conf where we learn a lot, and this is the day where I decided I don't care. I'm gonna wrap around DuckDB to build package. But like right now, we don't care. We are wrapping code from LLM, so we don't care. Oops. Okay, so at that time, we both worked for the Center on Rural Innovation. The goal of the center, it's a nonprofit. That's the goal is to unlock rural potential. For that, we want to create tech opportunities for rural communities. And one of these goals, and to achieve that, they need to have internet. That seems simple. But like if you want to call all of this LLM, et cetera, to write code, to build your own workflow, et cetera, you need a good internet connection, which sadly, it's still not the case. And I'm not working for Starlink, but Starlink is not good enough. Data as code. So if there's computer scientists here, sorry, I lied a bit. You will not see any abstract syntax tree here. Just this is the catchy name. What I want, really, like my key idea is like you do not fear anymore permanent storage of database at the end of this call. Like you are free to use them and you enjoy them. I'm gonna build my talk on using some already existing data package, trying to show their limits and advantages, and show you a new way of doing it. An easy and bad example. So you can write a simple application code. This is bash script that you can source it. They're just gonna load two functions. One that's gonna ask you like to give two parameters. Here, like the file name database do a lot of work. If I have called that file, it would have been like way more clear. And you can also have another function that's gonna get you something. Obviously, this is a dummy example, but it does something. It saves data somewhere, and it gets it. And basically what a database does is way better than that. Because this is using the operating system. If, for example, I want 3 parameters, I need to rewrite my own code. Like, nightmare. I mean, not nightmare, but I mean, job security. Okay, so the database management system and the relation adjective of it, the goal is to isolate that, like not depending on the operating system and building abstractions that your application can target instead of managing the storage, managing the files, like all this component. Like we have the database, basically it's built by we have the database storage, that's a file system, that's not very well. The physical schema would be like the file, for example, and the logical schema would be like, how do we represent that information and then we access it? And then you build application. It's not exactly true. Usually you have another layers here, but yeah, let's simplify it. I stole a lot of this idea, like by the way, so I try to reference the authors of them. If you have questions, do not hesitate to interrupt me. If every data was only on database now, would it be great? Well, I have bad news for that. If it was the case, we were all writing database migration, which is kind of a data engineering name to say like, oh, we are going to move data from one database to another. So we are basically moving data from one permanent storage. I slightly like because there's some database that are in memory to other space. But sadly, no. So we need to move data usually from some places. We call that upstream to the database storage. And this is important. And usually the upstream, like where the data came from, you have no control over it. This can be a total mess. And usually it is, for good reason. Okay, data package example. I'm gonna use that in the broad sense. Like, let's use SP data. I don't know if you have used it. SP data is a very nice package that contains data in 2 ways. So this is a package you can download. It's not on CRAN because it's voluminous package, so you need to download it from GitHub. And that's it stores data either like in the data folders or in the source version in ist, or if you install it, it's gonna be like in your wherever your light path is from SP data, and it's gonna move that. And it's store all the process on how you get this data in this data row. If you are read air package, this is what's advocated. You need, like, if you provide data in your package, you need to say how you make that data from some source. And it provides nice documentation. I'm gonna go quickly at that. So Upstream is data raw, or I get that. It's not exactly the upstream, but this is all the path that's leading me to get the data either in these two places in the package. Let's use the file system. The kind of file is specific, I don't mind it. You have no logical schema here. The goal is just like you load data and then you directly play with it. So application is minimal. Let's take another example. So this is Tigris. I don't think it's anymore on Cron. It's basically targets an FTP from the census. That's also a bunch of shape files that represent the US values boundary. It's very good at doing it, but still, like it's just a code example. Like you call it, you say like I want every block environment and get it. So it's good. Like it's actually your workflow reference all the process. The US census FTP is still amazing. I love it. It's like my best place on the internet. I don't know what's that tell about me. But Tigris, the applications that target it, do a lot of lifting. Are we gonna? Let's take a small example to help you. Like, let's say like I'm doing some census in 2000. I'm gonna tell you like my big beautiful census because I'm very original. And 10 years later, I need to build my big beautiful census again. And what I will do is like I will call in my FTP server, so it's gonna be MBC because and luckily 10 years ago I'm gonna call it MBC10. And all the match, like the user does not want to remember all that. That's what Tigris does. Tigris, like all the application code is like, oh, you require for 1980s, the FTP file with name will be like that, and you can get it. Okay. Oops. Tidy census. I don't know if you have used it. This one is on Cron. Here, this is the good example like you have seen like at the previous session. This is a web API. You build your application on top of it. You don't care. Every part, like how it stores, how it's like organized, what's the physical structures, everything you don't care. This is API is great. Quick example. It provides great convenience function. It's also cached on your hard drive, local hard drive if you want. A lot of very good functionality. All of that are valid approaches. They display also like quickly like on our package, like basically a convention how to store codes, can encapsulate complexity. And I think like the previous talk is a good example. Like also like this is also in our package that how it's really like simplify all of that for you. You can then abstract data as per your workflow, but how do we deal with bigger data sets? We will need to rely on external storage. And should we use logical schema? I hope so, and I hope I will convince you that they are cool, but I'm not sure. And I heard having like a modular framework is cool, so let's see if we can do that. So I will use like FCC, I never remember, like it's the Federal Commission of something, dataset and cori.data.fcc. It's basically they manage broadband and all the telecommunication stuff. This will, I will target two big data sets. The default of the FCC service and portal is like there's no nice FTP servers and the API is severely rate limited. Like it allows you like to get 10 row and I have that per rate. So like that was not an option. So they provide you with a website that you need to click, spread on multiple menus. This was totally unpractical. So the first step I have done that on how to make that. They did also at the beginning what I call sneaky updates. It's like they basically provide you the same file name, but like you need to check the timestamp because they could update it without telling you. That's very common. But at the end, they finally provide you in the file name like some kind of information. Look, we maybe have provided new data here. So quick notes. Like the last, like it's 22 gigabytes per release, and it's in zip format. Inside of a PostgreSQL instance, it's 100 gigabytes without counting index. So it's big-ish data. Like I said, the first step that I've done is the quick function to get all the data, not clicking on everything. And I use like a classic Postgres inside of RDS. Well, I get everything, then I move everything into a specific schema that the application targets. But that was nice, but I mean, there are some defaults. Like one release, and we see like we have 2 per year, and we are on the 4th years, is 100 gigabytes. we were a non-profit with not enough money to pay AWS, and I'm not gonna say you like go into AWS or go with what like it was one release was too big for our budget. Other points, analysts and scientists in my job, it's disappearing. That I was providing them a schema and then they need to deal with it. And they could write SQL, but they were not, for them, SQL was a barrier. And by the way, if some people think SQL is not a barrier, how many of you have read like the 2023 new SQL standards? Okay. So SQL can be a barrier. Even if it's simple, like it can be. Documents was spread, like in my code, document was spread in all of those repo, and it was like a mess to maintain for me. So instead, like this is the first recommendation. Do not use CSV, use Parquet. I don't know if you are aware of it, but like this is like the first step. Transform all your CSV into Hive partitioned Parquet. Well, Hive partitioned, I think it's good because like when you have a new release, you can just add like some kind of infig file hierarchy of the Hive partition packet. I don't know if you know what an Hive partition packet is. It's some way to represent like your release. Like you use a fake file system. Let's say like I have like release A, so everything will be like after release A and all my information, etc., etc. We can freely convert the metadata contained in file name into column. That's a nice features of Parquet. Instead of like if I have everything in CSV, let's say like one of my metadata is when the file is released, so I will store a timestamp. And if I store that into a CSV, I will populate my CSV with those file stamp. So I will lose a lot of memory, which Parquet is smarter enough to do like, look, this file is X long, you can repeat that X, it's not gonna change. I use DuckDB for that. I could have also used NanoParquet. Why? Because I think that DuckDB have a great CSV parser, because we live in the world of CSV, except people who deal with LLM who live in the world of JSON. It's implement like a logical schema, so we can enforce some data type and some constraints, and that's great to debug. That's great to alert you like some, for example, like I have like a house in Utah that have an internet speed that was in tera petabytes. Like I think I found like the Pirate Bay place. Multiple compression supported, that's a plus, and you can just tinker on that. And finally, DuckDB and the SQL from a Postgres are very close, and DuckDB an expansion. So I could use DuckDB and then send it back to my Postgres instance. Post communicate very well, which is a plus for me. Code sample. How do you do that? Like this is like how you process the data. I don't know if I have much time to do it, but it's basically like if you have used DBI, it's similar. Like you open a connection to the DuckDB instance. You specify like instinct data, so you're gonna need to write a bit on this. So this is what you specify here. 10 gigabyte was enough, but sometimes. And then like you say like, you write some classic SQL code. I don't want to go into it, but they have nice function that enforce like the typecasting, like PG. I don't know, that's very useful. And instead of this huge trick here, you can set each to an error, like ignore it. But you can also like specify like what do you do with an error. So you can also like ask, hey, look, do the ETL and then put the error away, and I'm gonna look at them after. So this is huge when we are like huge, but it's quite fast. And then similar like with if you have like published data in the package, usually you send that into data using a nice use this function that I don't remember. And I was a bit earlier. I said send that to an S3 bucket. So all the process of the data, it can be stored here in the data row repository of my GitHub. It's GitHub here, yeah. Like everyone, you should use S3 to store that mess. I'm saying everyone, but I'm pretty sure like every software pro is like managing S3 because it's dirty cheap. That was like solving our issue on like, and this is our issue, but like I'm pretty sure like you have a use case where you have big data that you want to access, and you want to access it easily. And this is like the same idea. So you can host that data into S3 as a Parquet file and save money. And because it's cheap, even a non-profit can do it. And I want, if some people work for some federal agency, I want you to believe it and provide data that way. And DuckDB has an extension to access S3. The slide default I can see like it's dynamically loaded, but no, I'm thinking not anyone care about that. So you execute two statements in SQL. That's going to load that extension that allow you to target the S3 object storage. Well, since DuckDB was built to be a nice R package, I have the link if you want to check that citation, that quotation. 5 minutes? Okay. Why not fully use an R package? You can move all my documentation into that package, use the vignette article you want. You can provide convenient function for your user, even though they don't want to write SQL. You can just grab them for that. And that's about it. Oops. I mentioned that, like, I'm kind of piggybacking the whole AI ecosystem on a package. This is an amazing ecosystem, so you can look at what others have done. And I want you to look at my implementation and criticize it, but I want other implementation to develop it so I can learn from you. Documentation, I mentioned it. You can like use command check, test, and more. Like package done is just amazing, no? Well, this is one example on how you do it. That's kind of paradox in some way. So you connect yourself to the DuckDB engine. You execute like some. This is like you're gonna have some writing to the disk still because it can be big. You load your way to connect, and you write a crappy SQL function with past and strict, which is bad. But that's fine. And you remember like to when you exit the function to close the connection. Okay. Potential improvement on that workflow. You can still fetch a lot of data and getting owned. That's your out of memory. So that's one way to improve it. In your DuckDB connection, you can read only. So you protect yourself a bit. And you can use prepared statement instead of pasting and sprinting. So like it will protect a bit of some SQL injection. But I have not tried it enough to recommend it. So how does it look like? So now all the upstream is stored in data row. The object storage, I put data away into an S3. The physical schema is still packet file. And I have a logical schema. That's everything that DuckDB can access that. I can access everything, and my application is very limited. So everything is stored in the package at version stored. If you don't want my custom function, you can still use DuckDB on the S3 packet. Like this is totally, and you can use another language, another API. I don't care. So this divide the task, this provide the data, and divide the task at multiple places. This is what I want to remember. Discussion. While using an R package, you still need to respect the convention. If you update the code RETL, you should relay that by the versioning of the package and then use Markdown. So your user know that. And you can look at the package that have not been done. I think it's a very good solution for big data with rare updates. Like you see, like the FCC data is released every 6 months. If you have more what you call a fact data, which is like a data for sales that is updated daily, maybe it's not the good way of doing it. You should use data warehouse or like some fancy magic with Duck Lake and Iceberg. If you have slow changing dimension, I guess a slow changing dimension is like, for example, the census. It's every 10 years, and we decide to Connecticut has decided like they didn't wanted 9 county, but they wanted 8. This is what they have done like few. So how do you decide to represent that in the past and no? This is what we call a slow changing dimension. It's hard to implement on the data representation, so it's depends. Why this package is not on CRAN? I still consider it experimental, so try it. The S3, the cost is super low, like it's pennies. So really like use it. And the benefit is very simple and high. But you still need to rely on an external storage. Thank you. So this presentation was built to the nice light-down package because like I advertise enough for AWS, so I can use less cloud intensive on Conberg, and the code repository is here and the emails.